Rate of chemical reactions. We will start with particles theory and collisions. Okay, what is rate of chemical reaction or speed of chemical reactions? In general, speed, like the general concept, speed is change through time, a change through time. In chemistry, speed of chemical reactions is change of amount of chemical substances over time. Okay, different chemical reactions have different speed of chemical reactions or rate of chemical reactions. And some reactions are very fast and others are slow or very slow. Instead of the word speed in chemistry, we use the word rate of reactions. Okay, rate of chemical reaction, I told you before, is change of the amount of chemical substances through time. Here we have three different types of chemical reaction. The first one is rusting. Rusting is a slow reaction, very slow reaction. If you remember, rusting is the chemical reaction between iron and oxygen that produce iron 2 oxide. Baking is a chemical reaction and it is relatively fast. And we have here another chemical reaction, explosive reaction. The explosion of firework are very fast reaction. They are okay. Why some chemical reactions are faster than some others? We use a theory. We will use a theory such as explanation. We have a theory, collision theory.
What were you saying?
According to this theory, reactions take place when particles collide with each other. Particles collide with each other, so they bounce with a certain amount of these particles, according to collision theory, these particles must have a minimum amount of energy. And this energy is called activation energy. And this energy is different for each chemical reaction. According to this theory, collision theory, particles must have the energy with light, and the orientation of particles must be a correct orientation for these particles. Collisions, which result in the formation of particles, are known as successful collisions. And if particles collide with less energy than the activation energy, they will not react chemically. They only will bounce with each other. So according to this theory, particles, to give a chemical reaction, they must collide. And also they must have this minimum amount of energy called activation energy, and they must have the correct orientation always in order to give a successful reaction, let's say. Okay, according to this theory, anything that increases the number of successful collisions between reactant particles, they will speed up the rate of chemical reaction. It means we have some factors that affect the rate of chemical reactions. The first one is the nature of reactants. Okay, what does it mean, the nature of reactants? You must probably have learned about the metals, the activity of metals, don't you?
Yes.
Okay, we know that some metals are more active or more reactive than some metals. Okay, let's take as example two metals, sodium and magnesium. Sodium is more reactive than magnesium. This is the nature of sodium. So this is what I mean with nature of reactants. If sodium reacts with acid, the reaction will be explosive. If magnesium reacts with an acid, the reaction will be fast, but not explosive. So on the rate of chemical reaction, also a factor is the nature of the material or the substance. The second one is the physical state or surface area of reactant. Okay, what I mean with physical state?
No, the last one.
For the same substance, for the same material, we have liquid and solid. Let's say, which physical state will be more reactive for iron? The solid iron or the liquid iron? Of course that the liquid iron. Why? Because the liquid iron has more energy. And the reaction, the rate of reaction for iron as a substance is faster. Always if we compare it with solid iron. And the surface area, I will talk about this factor, is another important factor. The next one, the third one, concentration of reactants. Concentration. Concentration, we have different types of concentration. We have percentage concentration, molar concentration. In rate of chemical reactions, we use molar concentration. Molar concentration expresses the number of moles of the substance in 1 liter of solution. And pressure. Pressure is an important factor, but pressure affects only the chemical reactions that are involved gaseous substances, gaseous reactants. Why? Because gases, gaseous substances have pressure. The next factor, one of most important factors, is temperature. And the last one, catalyst or inhibitors. Inhibitors are the opposite of catalyst. You most probably, you have learned about catalyst. I don't know about inhibitors. Do you know what are inhibitors and catalysts?
I don't know what an inhibitor is, but I know what a catalyst is.
Okay, catalyst is a chemical substance that speed up the rate of chemical reaction without being used up. Inhibitor is the opposite of a catalyst. If catalysts speed up, the inhibitors slow down the rate of chemical reactions. Okay, chemical reaction, they do not proceed at a steady rate. They start off with a certain speed and they get slower and slower until they stop. It means until the chemical reaction is finished. As the concentration as the reaction, the concentration of reactants decreases. These reduce the frequency of collisions. Frequency of collisions is the number of collisions per second. The number of collisions is frequency of collisions between particles, and so the reaction slows down. here on the first container, we have only reactants. These reactants here react together and will produce a product. Here, these reactants will react together and will produce products until the chemical reaction is finished. Here, 100%, the chemical reaction is complete. We use graphs to represent and to explain the rate of chemical reactions. Here is a graph, and this is a curve. In this graph, when on the y-axis we have amount of product, and in the x-axis we have time. So in this graph we have amount of products or amount of product over or versus time. Okay, how can we explain the rate of chemical reaction using this graph? The steeper the slope of this curve, the faster is the chemical reaction. If the curve is shallow, it means the chemical reaction is slow. And if we don't have a slope, there is no reaction. The rate of chemical reaction is 0, and it means the chemical reaction has finished. Do you understand it?
Yes, I do.
Okay, very well. Okay, here we have the same graph, but with reactants and products. Okay, concentration, we said before, concentration is one of most important factors. The higher the concentration of reactants, the faster is the rate of chemical reaction. Why here initially, or why at the start the rate of chemical reaction is maximal? Because the concentration of reactants is maximal, is the highest. And over time, the concentration of reactants is reduced. Why is reduced? Because they react and they form products. This is the reason why the rate of chemical reactions gets slower and slower until the chemical reaction is finished. Is it clear?
Yeah. Yes, sir.
Okay. Okay, how can we measure the rate of chemical reactions? Okay, we said before, the rate of chemical reactions is change of amount of substances, reactants or products over time. Here we have a chemical reaction between magnesium and hydrochloric acid. It will produce magnesium chloride and hydrogen. Okay, what would you measure here, or which substance would you use to measure the rate of chemical reactions in this reaction here? Any idea? What would you use, or which substance will can you use to measure the rate of chemical reaction here?
The amount of magnesium chloride.
Yes, yes, we can use, but we also have other other substances. Okay, remember, for chemical substances, for chemical reactions that involves gaseous substances, the best one is to use that gaseous substance. Why? Because we can measure the change of volume over time. And here in our chemical reaction, hydrogen is produced. So we can use the change of volume of hydrogen to measure the rate of this chemical reaction. But we also can use the the change of mass for magnesium chloride, hydrochloric acid, or magnesium. We can use all of them. Look, the amount of hydrochloric acid, the amount of magnesium chloride produced, but the best one, remember, the best one is the change of amount of hydrogen. Centimeter cube, decimeter cube, liters per minute per second, it doesn't matter. Important is that the rate of chemical reaction describes or expresses the change of amount over time. Here we have an equipment or the equipment that is needed to investigate the rate of hydrogen production. Here we have a conical flask. It has another name. Do you remember the another name of conical flask? Erlenmeyer. Okay, we need the reactant here is magnesium and hydrochloric acid, rubber for gaseous substance. Yeah, we need this gas syringe, and we can measure how the volume change over time for 1 minute, 2 minutes. Okay, how can the rate of chemical reaction be calculated from a graph? Here we have a graph for our reaction between magnesium and hydrochloric acid. We want to measure the rate of chemical reaction using the change of amount of hydrogen over time. Okay, we want to measure the average rate or the average speed from this point, from 0 to this one. Here. So rate of chemical reaction is change of amount. What is the amount for us? Is the volume of hydrogen, the unit centimeter cube. In this point, how much hydrogen do we have? 45. Here, look, is the half of between 40 and 50 is 45. What is the time? From 0
20 seconds.
And the rate of chemical reaction is volume over time. This reaction, it will be the rate of chemical reaction. It is the average rate, and it is 2.25 centimeter cube per second. This is the average speed. We also have instantaneous rate of chemical reaction or initial rate of chemical reaction. Here is, let's say, here we have some questions, and we have to put these boxes in the right box here. What will be the position of this one? How?
The second one.
Here?
Yes.
Yes. And this one?
The top one. Yes.
Yes, yes. This one, look.
The first one.
Yes. And this one? This one, this?
This one? No, I think you should move the second one up. The
Here.
first one up.
Here.
No, there, yes.
Okay, and this one? The
Black spot.
Yes, it is correct.
Let's see.
Wait a second.
You should try C.
Yes, yes.
Like, try clicking C.
For check, but I don't know, it's not working. But I know it is correct. Good job. Okay, we have another questions here. You have to choose the right word for each sentence. A chemical reaction can only take place when reactant particles
Collide.
collide with each other. Particles must collide with enough
Energy.
Yes. This is called
The activation energy.
Yes, very well. The rate of a chemical reaction depends on
Depends on the frequency.
Yes, the frequency. I told you before is the frequencies is the number of collisions per seconds. Changing the affects both the frequency and energy collisions.
Changing the temperature.
Yes, temperature. Changing the affects the frequency of collisions of dissolved.
Concentration.
Changing the affects the involving a solid reactant.
Surface area.
Yes, surface area. Well done.
Thank you.
Okay, now we will continue with factors. I will explain these factors. We will see these factors one by one. The first one, temperature. Okay, how does temperature affect the rate of chemical reaction? Essentially, the higher the temperature, the faster is the rate of chemical reaction. If we rise the temperature with 10 degrees, it will cause the rate of reaction to be approximately the double. So it will increase the rate of chemical reaction twice.
Okay.
But why? Why does the increased temperature increase the rate of chemical reaction? We will use particle theory to make explanations. Okay, at a higher temperature, the particles will have more energy. It means they will move faster and faster, and the frequency of collisions will increase. The higher the frequency of collisions, of course, the faster will be the rate of chemical reactions. But we have another reason here. When we increase temperature, we increase the energy. It means the number of particles that possess that amount of energy, the minimum amount of energy, will increase. So not even the frequency of collision is increased, but also the number of particles is increased. Number of particles, or the portion of particles that possess the activation energy. This is the reason why the rate of chemical reaction will increase. Here we have two containers. On both containers, we have the same number of particles. On the left, the temperature is low. On the right, the temperature is high. We will measure the number of collisions in each one, on which one container, for 15 seconds. Look, since on the left they move, the movement is slow of particles, the number of collisions is not very high. Meanwhile, on the right side, on the right container, then the number of collisions is very high. Why? Because these particles, red particles, they move faster. They have more kinetic energy. And therefore, they will collide more often with each other. The frequency of collisions is higher. Okay, we have here a concrete example why batteries are more likely to run down more quickly in cold weather. Any idea?
No.
Okay. If we at low temperature, when temperature is low or the weather is very cold, the reaction that generates the electrical current is slower than at higher temperature. So we need a specific temperature to turn on our vehicle, because our vehicle is connected with the battery. So this is the reason. The lower the temperature, the slower will be the rate of chemical reactions. So it's very difficult to turn on our vehicle. Do you understand it?
Yes.
Okay. Here we have a chemical reaction, a virtual experiment that explains how temperature affects the rate of chemical reaction. As example is taken the reaction between sodium thiosulfate and hydrochloric acid, and the product of this reaction is sulfur, solid sulfur. It has a yellow color. The color here is important, the color of sulfur. Look, sodium thiosulfate, hydrochloric acid produce sodium chloride, sulfur dioxide, sulfur solid, and water. When sulfur is produced, the solution will turn cloudy. Now we will see, we will watch this reaction in two different temperature, at low and at a higher temperature. Okay, on this paper, we will make a mark or a cross. Here we have done a cross. Okay, we will put on this paper a Petri dish. And if you see this blue or transparent solution is the aqueous solution of sodium thiosulfate. It's one of reactants. Then on this Petri dish, we will pour some drops of hydrochloric acid. Look, we have poured a certain amount of hydrochloric acid, and the chemical reaction will start. And we will measure the time in which the solution turns cloudy. When the solution turns cloudy, we cannot see anymore the cross we did before. So this is for a specific temperature. We will repeat the same reaction, but in a different temperature. And we will measure the time. Look, this chemical reaction is done at 25 degree and the time is 110 seconds. If we rise the temperature by 5 degrees, the time is reduced 80 seconds. If we increase with another 5 is 60, for 40 is 46, 45, 38, 50 is 30 seconds. What does it mean? It means if we increase the temperature, the time is reduced. But when time is reduced, it means the rate of the reaction is faster, has increased. Do you understand it?
Yes.
Okay, very well. And here the reaction is represented with a graph. Is time versus temperature. The higher the temperature, the shorter is the time. The shorter the time, the faster the rate, because time is inverse proportional with the rate or speed. Here we have, we will continue with another factor, concentration. The higher the concentration of reactants, the faster will be the rate of chemical reaction. And the lower the concentration, the slower the rate of chemical reactions. Okay, why does the increase of concentration increase the rate of chemical reactions? When concentration is increased, we have more particles per the same. Do you hear me?
Yes.
When we increase the concentration, when concentration is higher, we have a higher number of particles per the same amount of space. You know, we measure amount of space with meter cube, centimeter cube, decimeter cube, liters, etc. The higher the number, the greater the number of the particles, it means the higher will be the frequency of collisions. Why? Because we have we have a higher number of particles in the same amount of space. So these particles here will collide with each other more often than these particles on the left. We have on the left 4 particles in this container, and on the right we have more than 4, we have 9 particles. So
Yes.
here on the right they will collide more often, and the frequency is higher, the frequency of collisions. We will watch another experiment. We will measure the number of collisions, the frequency of collisions, for 15 seconds. On the left, we have 8 particles on the left, and on the right, we have more than 8. We can notice easily this change. On the left container, low concentration. On the right, high concentration. For 15 seconds, let's see the number of collisions. Look, for the same time, for 15 seconds, on the left we had 65, and on the right 269 collisions. Why? Because on the right, we have a higher concentration. So how concentration affects the number of collision and the rate of chemical reaction is easy. Here we have a chemical reaction. How we will study how concentration changes the rate of chemical reactions in this reaction between hydrochloric acid and magnesium. Let's start. We will take magnesium ribbon and we'll drop it on the acid. Then we will measure the time. We will measure the amount of hydrogen produced for 1 minute. Look, 14 centimeter cube for 1 minute. Now we will change the concentration of the acid. Here, the concentration of the acid is 1 molar. Do you know what does it mean, 1 molar? 1 mole per liter. Have you studied the concentrations of solution?
Not so much. Not so much.
Okay, we can study them together because in chemistry, concentrations of solutions are very, very important. Okay, molar concentration expresses the number of moles per unit of space, that is volume, in 1 liter. And the concentration 1 molar means 1 mole. 1 mole of what? 1 mole of hydrochloric acid in 1 liter hydrochloric acid. Look, for 1 minute 14, for 2 24, after 3 minutes 31, until after 10 minutes the volume of hydrogen produced will not change. What does it mean? It means the reaction has finished. Now we will repeat this experiment. The procedure is the same, but with another, or with hydrochloric acid 2 molar, not 1 molar, but 2 molar. The concentration is doubled, is the double. Look, if concentration of the acid is 2 molar, after 1 minute we have 29. For 1 molar was 14. So the curve on this graph, the red one, is for concentration 2 molar. And the blue one is 1 molar. I told you before, the steeper the curve of the graph, the faster the reaction. The more shallow the curve of the graph, the lower the rate of chemical reaction. Okay, now pressure.
Yes, sir.
How pressure affects the rate of chemical reaction? Why? I told you before, pressure affects only chemical substances that are only chemical reaction that involves gaseous substances. If pressure is increases, the space in which the gas particles are moving, they become smaller. So if we increase pressure, we are reducing volume. And when we reduce volume, we increase concentration. So when we increase pressure, the particles become closer together, and it will increase the frequency of collisions. It means the particles will collide more often with each other, and the rate of chemical reaction will increase. On the left, we have lower pressure. On the right, higher pressure. We have on both containers, we have the same number of particles, but on the right, the pressure is higher. The volume is lower, and when the volume is lower, the concentration is high. Look, pressure is inverse proportional with volume. Also, molar concentration is inverse proportional with volume, and the pressure is proportional with concentration, molar concentration. Another factor here, effect of surface area on rate of chemical reactions. Any reaction that involves a solid substance can only take place at the surface of the solid. If this solid is split into several pieces, the surface area increases. And if the surface area increases, the contact between particles will be higher. The frequency will increase. We have here a cube with lots of surface area and split in several pieces, 1 into 4 pieces. As the surface area gets larger, the number of collisions or the frequency of collisions increases. As the frequency increases, also the rate increases. So the smaller the pieces, the larger the surface area. The larger the surface area, the higher the frequency of collisions. Look here. Here we have 2 containers, and in this chemical reaction, solid substances are involved. The solid substance is the substance with the green color. On the left, the surface area is smaller. On the right is larger. We will measure the number of collisions for 50 seconds. Look, on the left, 71 collisions. On the right, 309 collisions. Why the number of collisions is higher? Of course, because the surface area is larger. Do you understand it?
Yes, I do.
Okay, very well. Here we have a chemical reaction between a carbonate and an acid. If you remember, if carbonates carbonates are salts. If they react with acids, they will produce a new salt, carbon dioxide, and water. Here we have the reaction between marble chips. Marble is calcium carbonate and hydrochloric acid. So it will produce calcium chloride, water, and carbon dioxide.
Thank Jesus, came out together.
Below the word equation is written the chemical equations with chemical formulas. We can observe or we can study the effect of increasing surface area on the rate of chemical reaction by measuring and comparing how quickly the mass of reactants decreasing using marble chips of different sizes. Here we have marble chips, and the total mass of this of both Endlmeyer with the acid, hydrochloric acid, and marble chips is 58. We will measure how the mass of this mixture will decrease over time. Look, we will drop the marble chips here and we'll measure. Do you know why the mass decreases, the mass of mixture? No? What you said, sorry?
I said, I do not know.
Okay. In this chemical reaction, look, in this chemical reaction, carbon dioxide is produced. This flask is opened, look, and so carbon dioxide can escape from this flask. This is the reason why the mass of the mixture decreases.
Okay, now I understand.
You don't understand it yet?
No, I'm listening.
Look, I want to show you a video on YouTube. Is interesting.
Today we're looking at the different factors that affect the rate of beakers.
So here we have three beakers, three different beakers, and in which one we have poured hydrochloric acid with the same concentration. And
Okay.
on the first, or
here we've got three beakers, each containing dilute hydrochloric acid, and these containers have got marble in them. The chemical name.
And on these dishes we have marble chips, so calcium carbonate. We will drop this marble chips with different form in these beakers.
For marble is calcium carbonate. Here the marble is divided up into fine powder. In this one,
on the first one we had powder marble chips.
Relatively, well, medium-sized chips. And here there's fairly large chips of
On the second one, we have small chips, marble chips, and on the last one, we have larger pieces of marble chips.
calcium carbonate. Now what we're going to do is going to put them into the dilute hydrochloric acid and just by observing it, make a note of the rate of reaction, how fast the reaction goes. In other words, how busy it gets. This is the one with the large chips. As you can see, the reaction's fizzing. It's not particularly rapid, but
Because carbon dioxide is produced, bubbles are produced on this container.
it's going fine. And the reaction shouldn't take too long to complete. For the medium-sized chips, however, you can see the reaction is much faster.
Look, the reaction here is much faster because more bubbles. The reaction is faster.
And then we come to the powdered.
And the last one, the powder.
Fairly obvious to see that the surface area, increasing the surface area, increases the rate of reaction.
So do you understand it?
Yes, I do. Thank you so much, sir.
Okay. Do you enjoy our lessons?
Yes, I did. It was really helpful.
Okay, thank you. Thank you so much. As I know, we will continue together. And I can teach you what you want. For example, you have not learned about solutions, concentration of solutions, but we can learn it together. They are